Hello everyone, class 12th, topic name important points in chlorination, bromination, iodination and florination of alkane. First we need to understand what these terms mean. This is alkane CH4, the smallest alkane, methane. Suppose I am reacting it with chlorine in the presence of sunlight or heat. One chlorine atom will substitute one hydrogen. Like this. There were 4 hydrogens, now we have 3 hydrogen and 1 chlorine. Out of 2 chlorine, 1 was attached with carbon, 1 will go with substituted hydrogen and side product will be HCl. These reactions are known as chlorination reactions of alkane. At the place of chlorine, if I am using bromine, same process will happen, we will call it bromination. Iodine, then iodination, and fluorine, then fluorination. Mechanism is free radical mechanism. These all reactions are happening through free radical mechanism. This we have already understood in the previous video. Now let's check what are the important points in them. In chlorination, the important point is relative rate of substitution of 1 degree, 2 degree and 3 degree hydrogen. As in previous video, we have understood in alkane, hydrogens can be of different type. Like for example, if I have this alkane, now what is the degree of this carbon? It's 1 degree carbon because it is directly attached to 1 carbon. So these hydrogens are 1 degree hydrogens. What is the degree of this carbon? It is 2 degree carbon. So these hydrogens are 2 degree hydrogens. What is the degree of this carbon? It is a 1 degree carbon. So these hydrogens are 1 degree hydrogen. Because their reaction is happening with free radical mechanism, substitution or reactivity order, if I call it reactivity order of 1 degree, 2 degree and 3 degree hydrogen. So 1 degree hydrogen is least reactive, then 2 degree and then 3 degree hydrogen will be the most reactive hydrogen. Means 3 degree hydrogen can easily substituted by a given halogen. Reason, mechanism, free radical mechanism we have. After 3 degree hydrogen substitution, we will get 3 degree free radical carbon, which is most stable carbon. And if 1 degree hydrogen we are substituting, so we are getting 1 degree free radical carbon, which is least stable carbon. So that's why we have this topic, relative rate of substitution of 1 degree, 2 degree and 3 degree hydrogen. 3 degree hydrogens are fastly substituted by given halogens and 1 degree hydrogens will be least substituted by given halogen. So the relative rate you have to learn, that relative rate is 5:3.8:1. 3 degree hydrogen, 2 degree hydrogen and 1 degree hydrogen. These rates you have to learn. This is the ratio of their reactivity, speed of the reaction by which 3 degree hydrogen is getting substituted, 2 degree hydrogens are getting substituted and 1 degree hydrogens are getting substituted by chlorine atom. Now same relative rate topic you have in bromination. So learn it. This is the relative rates of substitution of 1 degree, 2 degree, 3 degree hydrogen in chlorination. 3 degree hydrogens are mostly substituted. Then 2 degree are slower substituted as compared to 3 degree, and 1 degree will have least substitution rate as compared to other. In bromination, this relative rate of substitution will be 1 degree, 2 degree and 3 degree hydrogen is 1600 ratio 82 ratio 1. This is the ratio of rate of substitution of 1 degree, 2 degree and 3 degree hydrogen. 3 degree hydrogen substitution rate, 2 degree hydrogen and 1 degree hydrogen. These ratios you have to learn in chlorination and bromination. Now in iodination, what is the important point? Let's check. In iodination, important point is it happens in the presence of oxidizing agent. Suppose CH4, I am going to iodize iodine. The product will be CH3I plus HI. In this reaction, we need one extra chemical oxidizing agent like nitric acid, HgO, mercuric oxide. These oxidizing agents we need here. Why we need oxidizing agent? The reason is high reactivity of HI. Yes, this is a side product HI, and in HI the bond length is very long. Between hydrogen and iodine, the bond length, the covalent bond, the sigma bond is very lengthy. That's why it is very weak. And why it is so lengthy? Because of bigger atomic size of iodine. And we know long bonds are weak bond. So what is happening over there? As HI is generated, the bond will break, and this HI will make this reaction to move in backward direction. Means the reaction will go in reverse direction. Because the bond length in HI is very lengthy, it is a weak bond. So as it generates, it break, and when it break, it will react back with CH3I, due to which the reactants will generate back. Means HI presence is making this reaction to go in backward direction. That's why it is important to finish it out. Now, to finish it out, we are using strong oxidizing agents like nitric acid, mercuric oxide. When HI reacts with HNO3, it will create iodine and water molecules. You can balance it. In this fashion, oxidizing agent is finishing this HI in the form of iodine and H2O. This is the important point in iodination you have to keep in your mind. Like iodination will happen in the presence of oxidizing agent. Reason, this side product HI, which is highly reactive due to very lengthy bond, and that high reactivity make this reaction to move in backward direction. This HI is going to react again with CH3I, and it will give back the reactant product. Now to finish it out, we are using strong oxidizing agents. Reaction will happen and it will finish to iodine. Now in fluorination, what is the important point? Let's check. Florination. Like in chlorination, we are using direct chlorine. In bromination, we are using directly bromine. In iodination, we are using directly iodine. But in florination, we can't use directly fluorine. Reason. In fluorine, the bond length is very short, due to which lone pairs on fluorine are very close to each other. That's why repulsion is existing between these two atoms. Because already repulsion is there, so this bond can break very easily. Means fluorine molecule is highly reactive. That's why its reactions are uncontrollable. Now secondly, when it reacts with alkane, and we know the reaction is happening through free radical mechanism, and in free radical mechanism one step is there in which carbon free radical combines with halogen free radical. Like in this case we have a fluorine, so fluorine free radical will be there and CF bond will generate. This step is highly exothermic. Lot of heat energy is evolved during this process, this step. And that heat energy is uncontrollable. That heat energy even can break carbon-carbon bonds which are present in alkane. So much heat energy is evolved over there, due to which even carbon-carbon bonds will break in alkane and fission of alkane will happen. That's why we don't prefer direct fluorine for fluorination process. Then what is the alternate? The alternate is, if you need fluoroalkanes, one option is you can use like CH3Cl, already chloroalkanes, or you can use bromoalkanes, which you can react with inorganic salts of fluorine like silver fluoride or arsenic fluorides. Now if I am using silver fluoride and I am going to react it with CH3Cl, so due to electronegativity difference, it have a positive charge, it have a negative charge, and in silver fluoride we know silver is carrying +1 charge, fluorine is carrying -1 charge. Positive will attack on negative, negative will attack on positive, bond breakage will happen and you can get CH3F. Side product will be AgCl. In a same fashion, you can replace bromine by fluorine. It is much safer process as compared to direct fluorination. This is first option that we can adopt. Second option is, this was first option, and the second option is you can use diluted fluorine. Diluted fluorine means in a container with fluorine molecules, we can add some more gases like nitrogen or argon. Nitrogen and argon are very less reactive gases, so they will not interfere the reactivity of fluorine. Only what they are doing, they are just decreasing the number of particles of fluorine, and if number of particles of fluorine will decrease, so that heat energy which was evolving too much will be decreased and we will not have a problem of fission. So these are the two options we can prefer for the fluorination, but direct fluorination from fluorine is not a right option. Reactions will be highly exothermic and uncontrollable, which we don't want. So that's it. These are the points, important points we have in chlorination, bromination, iodination and fluorination of alkanes. Thank you very much for watching the video.